sides, you are looking between pi over 2 to negative pi over 2. When you did that, you would place that root 3 over 2 by knowing that it's positive, so it came up to the first quadrant. You know that this was the root 3, this was a 2, and there gives you 1. So from there, you then knew that the corresponding angle that gave you the sine value of root 3 over 2 had to be 60 degrees. So that's what we've been working on. Now, what's going to happen different today is that where else is sine positive? Second quadrant. So what we're going to do today is not only list the angle that's here, but we're going to reflect it to the other sides that give you your positive values or negative values and things like that, depending upon what the question's asking. That here again, we have a root 3 over 2, but that's not 60 degrees here, it's 120. And that's kind of what we're getting at. But in order to do that, we have to have specific parameters set. So what we're going to do today is we're going to do this. We're going to solve the equation. It's going to look like this. Sine of x equals root 3 over 2 between 0 and I believe they write it like that with the less than or equal to. So you include 0, but you don't include 2 pi. And yeah, okay. So instead of, and the only other thing that I needed to change here, I just wrote x, it should be theta, but we'll get to that. So what this means is, how do you get sine by itself? Well, how do you undo sine? You would have to inverse. So what you'd wind up doing here is x would equal the inverse sine of that root 3 over 2. So you're doing what you did yesterday, but now it's asking you by saying, what are all of the angles within one revolution that have that sine value? That's what that means with that parameter, between 0 and 2 pi. Does that make sense? So you still search for it like you would normally in the first spot, and then you figure out where else does that value occur, whether it's first quadrant, second quadrant, first and third, second and fourth, could happen in all 4 quadrants, things like that. All right. Then? I don't have an example. It's going to give you a pop quiz. Yeah, this is one. So we'll solve this. 2 times the sine of x minus 1 equals 0. And I'm not worried about this general solution. We're not there yet. We're going to do all of this today. Is going to be within one revolution. Notice that it's in radians by 2 pi, which means my answer should be radians. Just a little reminder there. You're welcome. So again, what you're looking at here is an equation. 2 times the sine of x minus 1 equals 0. Work backwards like you would normally. What would you do first? Add 1, right. What we would do is we'd add 1, we get 2 sine, then what? Divide by 2, very good. Then what? Inverse. What angle has a sine of 1/2? 3 degrees. Good. Where else is sine positive? Second quadrant. So again, this becomes very visual. We know it's at the 30 degree here, which means that if I bring it over to the second quadrant, there's my 30 degree up. So that it's going to be at 150. So it's at pi over 6 and 5 pi over 6. You're utilizing the stuff that we've been doing with an added step. Okay. Basically just an added step. Excuse me. there's going to be problems that you guys are going to hate me for on some of these. But it takes, if all the sections in trig that we do, this might be the one section, this and verifying, these two sections generally take the longest to get through. I anticipate us working through these types of problems over the course of the next, 2.5 days, which tomorrow's a half day. And then come Monday, we'll put everything back together, and I'm still planning on doing like our quest, if you will, Tuesday. So if by chance you are dead on Tuesday, but you're alive on Wednesday, you can still take that test then on Wednesday. But if you're dead on Wednesday, then you'll have to take it rather quickly on Thursday because it's a half day. No stress. Or better yet, if worse comes to worse, because on Thursday we do have, if you happen to be dead or sick and whatever, if worse comes to worse and you have to do it on Thursday, you just have to come in during conferences and just sit and like. What do you do first? Subtract 1, then what are you going to do? So everybody okay, but we can kind of skip a step or two here to say it's going to be cosine of x equals negative 1/2? Because it's negative 2/4. Are you all right with that? Perfectly fine to do that if you'd like. Otherwise, write out your steps. It's not a big deal. No problem at all. Okay. So now you go back to the same thing. What angle has a cosine value of negative 1/2? Well, cosine being negative has to go to the second quadrant. -1, -2, here's my √3, which means what's that angle? 60. Now, in the second quadrant, it's going to be obtuse, so it's not pi/3, it's 2pi/3. So this is 2pi/3. Now, where else is cosine negative? Third quadrant, very good. Third quadrant, so I drop the third quadrant down 60 degrees, which means that this is still the negative √3, -1, and 2, so I'm still negative 1/2. If I move down off of pi 1/3, I am at 4pi/3. There's my answers. And this all comes back to the idea all students take calculus. Everything's positive, sine's positive, tangent's positive, cosine's positive. All things. Oh yeah. Games usually like this. Tangent. Right. Okay. Oh no. Right. Yep. Now, Caleb just mentioned this when he started moving stuff around, and he kind of caught himself as he was saying it. When you get to when you're trying to solve for x here, obviously we wind up with tangent of x is going to equal 1/√3. 1/√3. When I'm going to sit there and place that to figure out what angle that has, do I need to rationalize that? No. You don't need to rationalize these parts because this is that visual of it, because you know at what angle is going to have a tangent value of 1/√3. Well, that means that my tangent's positive here. Here's my 1, here's my √3. So what it has the opposite of a 1 and adjacent of a √3? 30. So that means it's at 30, okay? But that means that's pi/6. Now, where else is tangent positive? Which one? That would be the third, yes. Tangent is positive here, So I move down a pi over 6. So what's 1/6 more than a whole? Okay. Get into what you were asking me. What's opposite? Tangent's opposite over adjacent, isn't it? If my opposite is -1 and my adjacent is -3, what's -5 by negative? Is that how it works? Okay.
Oh, you just subtract. No. Yeah, you just subtract.
Hold on. It's okay. Hold on. Hold on. Guys. So what this means is sine of x times the tangent squared of x equals sine of x. Okay. When they put these together like that, they do not put the little dot to show multiplication. They just put them next to each other. Okay. Now, think about what you would do normally if you had to solve an equation. A lot of times when you see squared things, that meant you had to get one side equal to what? 0. Okay. So here's a little hint. Think of this sometimes when you see squared stuff that you might have to treat it like you would a quadratic. Now, not to say that we're factoring anything yet, which we will. What's that? Now, someone mentioned it a second ago. If I set one side equal to 0 and I have to subtract the sign over, be okay with that? Now, if I subtract the sign over, does it take away the sign that's already on the left? No, it doesn't, because it's being multiplied. Okay? So if you subtract the sign, you want it with sine of x times the tangent squared of x minus the sine of x equals 0. Do you still agree that there's a squared term here? Now, when we did squared terms before, what would you do if this looked like what would you do there first? Factor out the 2, right? Okay. What do you do there? Factor out the sign. When you have two terms being multiplied together that wind up being set equal to 0, just like we did before, didn't we set both of those terms equal to 0? It works the exact same way here with trig. Now that I have two terms, I can say sine of x equals 0, tangent squared of x minus 1 equals 0. And I can solve both of those independently. Now, sine of x equaling 0, that means what angle has the sine of 0? So we draw our diagram. Sine is which coordinate, the x or the y? It's the y coordinate. So we have to figure out somewhere on a quadrantal where our y values are 0. Where were they? 0 and 180, but we will say 0 and pi. Are we okay with that? I have sine, the angle that has the sine of 0 is at 0, and it's at pi. So there's one set of answers. Tangent squared of x minus 1 equals 0 means I have to do 1 first. Add 1, very good. So I have tangent squared. How do you undo squaring? Square root, what's the square root of 1? 4. The function itself is squared. So it means when you don't write it as tangent x squared, it's tangent squared of x. Okay. So now I'm at the point of what angle has a tangent value of plus or minus 1. By now, you guys probably remember, where does tangent equal 1? What triangle has to have that happen? In the 45s, right? Because when you're at a 45, 45, 90, your opposite and adjacent are always the same. Well, if you're at a 45, 45, 90, you're looking for tangent to be plus or minus 1. In the first quadrant, it's plus 1. Second quadrant, it's negative 1. Third quadrant, it's plus 1. And the fourth quadrant, it is. So there's your example of what can happen. You can get them all four quadrants. What's happening here is you have a 45, 45, 90. You're 1, 1, root 2. That reflects all the way around. And that creates a square. Remember that from geometry? If you have side lengths of 2, you have a diagonal then of 2 root 2. This is why 45, 45, 90s work. Anyway, so what happens here, you're at pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. All 4 quadrants, tangent is either positive or negative 1. So this equation technically has 6 solutions. 0, pi over 4, 3 pi over 4, 5 pi over 4, 7 pi over 4. And now you wonder why I'm always smiling when I'm doing work with trigs. There's just so much going on. Okay? This is the type that you will see. That's the little trick you'll see. When you see a squared thing with 2 other parts, a lot of times it means you'll be factoring something out. We haven't gotten to the point of understanding how identities work yet, but there will be other tricks and things when we get to it. No, I had another one. I didn't. Yeah, I did. You know I did. You know I did. I have more. I always have. Yes. Do. These are all the problems that we're doing today are all going to be what we call within one revolution. We will worry about the terminology called general solutions later. We'll probably talk a little bit about that tomorrow. It's basically the same stuff. The general solution things just adds an extra, adds like a little. It becomes the nomenclature you do for the solutions are a little bit different, and we're going to be working off the same things. So. I don't have any passes. You're late. You need passes. I don't have any passes. I don't have time to write. So what do you do here? What do you do first? Subtract 3. So if I subtract 3, I get negative 3 cotangent theta is 3. Theta, or x, they're interchangeable. Okay. Now what do? Divide by -3. So now I have cotangent of theta is -1. When I get to this part here, a lot of times I've always felt that it's easier to use the standard trig functions versus the inverse trig functions. Since I might get mixed up. Pleasure. This one's not so bad because it's just cotangent. But if it's cosecant or secant, sometimes you would do an inverse here. So cotangent's the inverse of what? Tangent. So this is the same thing as asking, what is the tangent? What's the inverse of -1? It's nice when it's tangents once because it's the same value. So if I look at this now, it's asking me what angle has a tangent of -1. Well, that means that when I'm looking for tangent values to start being -1, I initially always start looking like we did before. And this is -1, 1. So this is my -45. But remember, our parameters are always between 0 and 2 pi. So I can't say -45. I have to use it as, this is my reference angle of 45. Oops. If I come around, I'm off of the 2 pi by a quarter. So what's 1/4 less than 2? Right, 7 pi over 4. So here I'm at then 7 pi over 4. And where else is tangent negative? Second quadrant. Second quadrant, I'm up a fourth, which means I'm at 3 pi over 4. Yeah. That's for when you have just this part. If you have just a problem like this, you're looking for it that way. When I have this parameter, it supersedes it. You still start like we did yesterday. We still started where it would initially look for it. And then we did look to see where else does it occur, but we have to make sure we write it in terms of one revolution, not just a negative drop. Okay. And that's what sometimes takes a minute or two to get used to. Yes. Right now it is. I have time to go downstairs. What do you do first? Add 3, good. So we add 3. Then what? 5 by 4. You okay if I just wrote it backwards? Well, I'm doing it anyway. Here's an idea. A second ago, I always said that a lot of times I like to rewrite my solutions in terms of the reciprocal functions or your standard trig functions if I'm given a reciprocal. So secant theta of 2 is the same thing as saying cosine theta of 1/2. They're reciprocals. In my mind, I think it's always easier to do it that way. If you don't want to, it's no big deal. No one's forcing you to. So we go back, we figure out, all right, where's cosine positive? Cosine starts being positive in the first quadrant. And cosine is adjacent hypotenuse, so if my adjacent is 1, my hypotenuse is 2, which makes this is 60, which makes this pi over 3. And where else is cosine positive? 4. So if I went up pi over 3, means I have to go down pi over 3. So what's 1/3 less than 2? Very good. You don't need a unit circle, guys. You just need to know what the placement is, and adding and subtracting halves and quarters. Not lying to you about this. Not really. Hi, Sarah. Good to see you again. So 2 sine fourth x minus 2 or sine squared x equals 0. What are you going to factor out? Good. Factor out a sine squared. Very good. You factor out a sine squared. You're left with 2 sine squared x minus 1 is 0. Do I have 2 terms that are set equal to 0? So I can set both terms now equal to 0. Well, one of these 2 equations is going to be a lot quicker to solve than the other. You're right. The one on the left, we have sine squared x equals 0. To get rid of the squared, you'd have to square root. What's the square root of 0? Are you sure? Square root of 0 is still 0, yes. So this is asking you what angle has a sine value of 0. Okay. And we just did that one not too long ago. It was 0 and pi, if I'm not mistaken. It's where your y values are 0. Okay. So that one's pretty quick. We know that that's at 0 and pi. The other one takes a second to go through. What do you do first? Add 1, and then you would divide by 2. Good. So now you have sine squared x equals 1/2. Square root. Good. So when I take a square root over an equation, what do I over an equal sign? What do I have to write for the one side? Plus or minus. Very good. So that means that this is saying sine of x equals plus or minus 1 over root 2. I'm going to leave it like that, unrationalized, because it's easier to draw. And it goes again, what angle has a sine value of plus or minus 1/2 of 1 over root 2? Which triangle had the root 2's? 45. So sine is opposite hypotenuse, so that means you are a 45. So sine is positive in first and second, negative third and fourth, which means it's all 4 45-degree angles again. So you're at pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. And you get 6 answers. Huzzah! I know that it gets, no, I hate to say this, but it does get messy. It does get messy. Bless you. Bless you. All the good stuff. We made good songs, we had a mini with Darth Vader, we had trig. Alright, so let's see here. To start with these things, obviously, there's a lot of weirdness that can happen here. Which ones we want to start with? I don't want to go Yeah. Don't pay attention to what section. Yeah, page 1, page 2. It's so easy. Yeah, you have to believe me. It's literally 2 steps. It is. It is. I'm not worried about that yet. Those of you guys that are bailing on us, there's a lot more involvement to this where we're going to get. I'm going to try. I'll probably get to what we call an identity, where sometimes you'll have an equation. If you look on the third page, if you look at the third page, number 12, it says 2 sine squared x equals 2 plus cosine x. It's tough to solve for you can't solve for 2 different trig functions at the same time. So you have to be able to rewrite one in terms of the other. So there's an identity that says sine squared plus cosine squared is 1. Because that's Pythagorean. Your sine is your opposite. You do your opposite squared plus your adjacent squared, you're going to get your radius squared. That's why that works. So what will happen is we can say that sine squared of x is 1 minus cosine squared, or cosine squared is 1 minus sine squared. We use a little bit of that substitution trick for problems like 12, where you're given something in sine squared and then you have a cosine singular. You'd rewrite the sine squared in terms of cosine squared to therefore factor. So we'll do a little trick once like that. I don't know if we'll get to the secant tangent ones, but that's kind of like the one little oddball. But we might also talk about what's called general solution. General solution is going to be, if it happened to be in all 4 quadrants, what's the easiest way to write it? Well, if it's pi over 4, pi over 4, pi over every one of these, they get from here to here, here to here, here to here, here to here. They're all pi over 2 away. So I can say it's pi over 4 plus pi over 2 and for replication. If they happen to be just in 2 opposite quadrants and they're pi away, I can say something plus pi n. Or if it takes me to get from here all the way around, I can say plus 2 pi n. And there's little things like that. That gets a little weird, but I'll have everything posted and go from there. But I think for the most part, we'll probably be just picking and choosing stuff off of this for the next few days. Yes, ma'am.